The section 3.3, it's covering complex and rational zeros and polynomials. We're going to have old topics come back, like long division and synthetic division, and a concept called multiplicity, which you briefly discussed when you were in Algebra 2. So multiplicity is when a solution to a polynomial shows up more than once algebraically. And we will find that when you have what's called even multiplicity, meaning the solution shows up twice or 4 times or 6 times, we're going to have what's called a bouncer. It's not the official term, it's just what I use. And when you have an odd multiplicity, you're going to have an extended intersection. Now it's still going to intersect the x-axis at that point, but it's going to kind of hang around that intersection point longer than a traditional zero would. And we'll see what that looks like. So this particular polynomial is already factored, and if we looked at it on our calculator, which I'm going to do, we would just simply type it in. So y equals, goodness, y equals 2 parenthesis x plus 1 to the 3rd power, which means that that factor shows up 3 times. There's an odd multiplicity, and we'll see what that looks like, times x minus 4. So that factor shows up once. So I'm going to zoom 6 to a standard window, and you're going to see a 4th degree polynomial, kind of. Now it turns out I can't see the bottom of it. It doesn't really matter for our purposes, but if you want to be able to extend this down to, like, I don't know, negative 50 is probably fine. Oh, no, not. Goodness. Let's go negative 100. If this doesn't work, then I'm just going to give up and stop trying to find a window because it doesn't really matter. Oh, goodness. So it's a really strange looking W. And you'll notice it had an intersection of the x-axis right here, which is at negative 1, and then right here at positive 4. And if I look at my factors, sure enough, that's exactly what I see. So when someone asks you, what are the zeros of that polynomial, you're going to say that you have zeros, whoops, I already have the word at, negative 1, and then you're going to put a little signifier multiplicity 3 after it, meaning that algebraically that answer shows up 3 times. And you also have a 0 at positive 4. Now they didn't ask us about x-intercepts. X-intercepts and zeros can be different answers. An x-intercept would be where the function literally intersects the x-axis. Turns out both of these were x-intercepts. We're going to see a case coming up where they're not both x-intercepts. So, and I didn't sketch it, but that's because we already had it on our calculator, but I would like you to sketch it in your notes because you will be sketching it in your homework. So number 2, let's take a look at our calculator. We are going to type the function, and I'm probably going to go back to a standard window after this, because I'm really only interested in the x-intercepts or the zeros of the function if they aren't x-intercepts. Oh goodness, can't type. And then x minus 3 to the 4th power. So this time we are going to see some multiplicity of even numbers, 2nd power and 4th power. Make sure I have it typed in right. I'm going to do zoom 6. And we're going to see a 6 degree, ooh, polynomial. I don't think this is a great window even for us. I'm going to shrink my window down. I'm going to go negative 5 to 5. Negative 5 to 5. And let's try that, see if it looks a little better. Kind of. This little pixelated part here, it's really difficult to see what's going on, but just because I know what's happening here, it is a curve. You could try shrinking the window further. You could go, negative 3 to 5, and maybe for y's we'll just go negative 3 to 3. Maybe we can see it a little better now. Nope, we can't, but that's okay. So what I want to point out to you though is the fact that algebraically I realize, yeah, these are zeros because they are, once it's in factored form, if I were to solve both of these factors, I would get a 0 at negative 2, but I see that since it has the 2nd power, it's got a multiplicity of 2. And we have another 0 at 3 with multiplicity 4. Now, looking back at the graph, I want you to realize, even though this is a cruddy picture, that it sure does bounce off at -2 as opposed to intersecting the x-axis, and here it bounces off at 3 instead, as opposed to intersecting the x-axis. And if you tried to find your zeros, they're going to find them on the calculator usually, as long as your window's decent. But it's not necessarily, these are not considered x-intercepts. So if your book says, name me the zeros and then indicate which ones are x-intercepts, in this particular case, none of them are x-intercepts. So a little bit of notation for you today. So even multiplicities, as we just noted earlier, they are bouncers. They're going to bounce, or bouncers. They're going to bounce right off the x-axis. I'm sure you noticed in the fourth power, it kind of hung around the x-axis a little longer before it bounced off, and you're going to see that the higher the even multiplicities are, the more long it kind of stays around the 0. And then odd multiplicities will they're kind of linger, around the 0, and they will eventually intersect. So if you have an odd multiplicity, you will have an intercept. Can't write today. Excuse my writing. So number 3, determine the degree of the polynomial, name the zeros and their multiplicities, and determine which are x-intercepts. So if you notice, this is 3 answers here, 2 answers here, so the degree, if I add those together, it's a degree 5 polynomial. And the zeros are, this factor, when I solve it, would be a -8 of multiplicity 3. And then this factor, when I solve it, would be a 6 of multiplicity 2. And remember our rule about even and odd multiplicities and whether that means they're x-intercepts. So the only x-intercept that we actually have in this problem is at -8, because this is the x-intercept. The multiplicity of 2 would make it bounce off, and it's not an x-intercept. Number 4, I'm going to watch my degree here. So I have a 3, a 2, and then here's an invisible 1. So his degree, when I add those together, is 6. And his zeros, algebraic zeros, let's see, I'm going to solve this factor first. So -4 of multiplicity 3. I also have a +3 of multiplicity 2. And then a -1. Since there's a multiplicity of 1, technically, you don't have to write anything. We assume it's multiplicity of 1. So the last part of the question, which of these are x-intercepts? Only those with odd multiplicity. So -1 is also one of them. So x-intercepts at -4 and at -1. Write an example of a function with these given zeros and leave it in factored form. I'm actually going to take that a step up because of the homework I'm going to have you do. I don't want you to leave it in factored form. I want you to write it in standard form because you guys are college algebra and we can do it. So zeros at 3 with multiplicity 2 and also a 0 at -4. So my polynomial function, I'm going to name it p of x. If he's got a 0 at 3, that means his factor was x minus 3. But see how they say multiplicity 2, that means it shows up twice. And then x minus 4, his factor would have been x plus 4. Now I'm going to FOIL this out. I might not do this on both just because I'm going to be a little lazy, but on a worksheet coming up for your homework, it does ask that you write your answers in standard form. So foiling out x minus 3 times x minus 3, I would get x squared minus 6x plus 9. And then I'm still going to multiply that by the x plus 4. So we have a tremendously large foiling problem now, or distribution. X squared times x is x to the third. X squared times 4. Well, I should go this way. 4 times -6x is -24x. I'll lose track if I distribute the other way. 4 times 9 is +36. And then do the same thing. Oh, darn, I think I screwed something up here. I'm going to go out of order. I would have been okay eventually. Sorry. Scribble. Oh, jeez. I'm on a roll today, guys. I'm going to distribute the x to everybody first in black. Sorry, I have a very OCD method of distributing things, I think. So, apologies. And I'm going to do the same thing. This was a +4, I believe, with +4. Distribute them to everybody. So let's see, it's a positive 4x squared. I have a, oh goodness, negative 24x and a positive 36. Sorry if I just made you scribble a bunch. So x to the third minus 2x squared, oh goodness, minus 15x plus 36 is my final polynomial function. Now the next one, for the sake of my time, I'm not going to factor it out, or I'm not going to FOIL it out. I'm going to leave it in factored form. The important thing is that you know how to set it up, because I know you guys can FOIL. If I have a 0 at 2 with multiplicity 3, the factor would be x minus 2, but raised to the third power. And then a 0 at 5 would be x minus 5 of multiplicity 2. So on purpose, I am not factoring that out. Okay, I need a book. I'm going to grab my textbook, and hopefully you have yours. I am not going to rewrite this whole thing, so sorry. It's on page 285. I'm looking at number 15, and I'm seeing a lovely polynomial, and they want me to use the given information from the graph to come up with a polynomial of least degree. So we're not going to worry about any extra zeros that I can't really tell are there, imaginary zeros, and I'm also not going to worry about coefficients. What I notice is this guy has x-intercepts at -2. He also has an x-intercept at 1. He also has an x-intercept at 3. And none of them are bouncing off, and they all seem very normal. So what that means for me is x-intercept at -2 is a factor of x plus 2, and then x minus 1, and then x minus 3. Now again, on your worksheet you're going to have for homework, they are going to want your answer distributed out into standard form, but the directions in the book here say leave it in factored form. So, and then it says indicate the degree of the polynomial. First power, first power, first power added together, so the degree is a third degree polynomial. Again, they had us assume that it was the lowest possible degree, so we're assuming there's no weird imaginary answers. Okay, number 17 on the same page is interesting. There are actually no x-intercepts, but we have a couple bouncers. So we have a bouncer at, let's see, -2, and it just quickly bounces off, and then also a bouncer at +1, which kind of indicates to me that both of these zeros have multiplicity of 2 on both of them. So when I go to write my function, a factor of x plus 2 with multiplicity 2, so it will bounce, and then a factor of x minus 1 with multiplicity of 2, so it will bounce. I like those. I think they're neat. Okay, this is fun. So we're going to give you a big ugly polynomial. I'm going to give you a hint, and I'm going to say, here's a 0 to start with. You're going to do synthetic division to break down a large polynomial to a smaller polynomial, and then you're going to be able to find the rest of the answers through quadratic formula or factoring or completing the square. So there's something called the fundamental theorem of algebra, where when your parents used to do this, they would have to be either told a place to start or they'd have to test a place, and there's a lot of rules they had to think about. We're not going to do that to you today. So they're telling you -1 is a 0, and I know from the last lesson that if -1 is a 0 of my polynomial, when I do synthetic division, that means the remainder should be a 0. And we will find out that that is true, unless whoever told us this lied. So 1 times -1, that's an 8. This is a -8, that's a 16. That's a -16, sure enough, the remainder is 0. Now what we are left with here was a cubic divided by a first degree, so now I have a quadratic left. So I have 1x squared plus 8x plus 16, and they want me to find all the zeros. So I'm going to take this quadratic, set it equal to 0. Turns out this quadratic does indeed factor. And it factors nicely. So the solution of -4 shows up twice, so make sure you note that it has multiplicity of 2, and that's all they wanted. So the zeros are, zeros, -1 and -4 of multiplicity 2. Now if they asked me which of these zeros are x-intercepts, only the -1 is an x-intercept because he has an odd multiplicity. -4 would be a bouncer. Okay, number 10. Ooh, cute, half. So we're going to do synthetic division with a half, or a 0.5 if you prefer to write it like that, to -17. I already don't like this very much. 90 and -41. Now we know if that's supposedly a 0, that the remainder should come out to nothing. So bringing down the 2 times 1/2 is 1, add those together, -16. Let's see, that's a -8. That would be an 82. Half of 82 is 41. Yes, the remainder is 0. We are left with now a quadratic, because I took it down one level from a cubic. And it's a gross quadratic. First thing I notice, everything here could be divided by a 2. So I have x squared minus 8x plus 41. Oh, that is not going to factor. So my options are quadratic formula or completing the square, and you know I love completing the square. So I'm going to do that. Subtract the 41 to the other side, leaving blanks. Half of negative 8 and then squared would be a 16. So we have x minus 4 squared. And then for some reason I can't add. Negative 41 plus 16 is negative 25. Oh yeah, duh. So when I square root both sides, I get x minus 4 equals plus and minus 5i. And my final answers are 4 plus and minus 5i. Now, I don't know if the directions said only find real zeros. If they did say only find real zeros, I don't even need these answers, but I think it just said find all zeros, so that indicates real and complex zeros. We just found 3 of them, 3 total. So 1 0, which also happens to be x-intercept, and x-intercept is at 1/2, and then the other 2 are 4 plus and minus 5i. So a couple things to note here. The complex answers, of course, are not x-intercepts because they don't cross the x-axis. The other thing to note is that the complex answers came in a conjugate pair. 4 plus 5i and 4 minus 5i are both, they're conjugate pairs of each other. If you have a complex solution to a polynomial, his complex conjugate twin must also be a solution. We'll come back to this in the next lesson. Okay, in this one, we are given 0 help. So if you wanted to learn fundamental theorem of algebra to figure out what you should test, by all means go ahead. But we're going to cheat really bad, and we are just going to graph this on our calculator and get a starting point by seeing where there are some obvious x-intercepts. So standard window would be fine, because all I'm interested in is where he crosses the x-axis, or at least bounces. Oh, I'm seeing, oh goodness. If you go to your table, they're not integers. So what that tells me is I'm thinking like this is a 1/2. So what I'm going to do is I'm going to pull up the trace button, I'm going to type a 0.5, and if it comes out to a y is 0, I'm correct. Yep, 0.5 is a good starting point for us. The other thing I notice is it does intersect 3 times, indicating to me that the 3 answers I get are going to be, they're going to be real, they're not going to be complex. So doing synthetic division with a 1/2 or a 0.5, be careful setting it up. I have a 2, and then I have a negative 5 for the quadratic. I have no linear term, and I have a 1. So make sure you put your placeholders down. So synthetic division, 2 times 1/2 is 1. This is a negative 4 times half is negative 2. Negative 2 times 1/2 is negative 1, and we did well because the remainder should be a 0. Remember, this is a quadratic, so I have 2x squared minus 4x minus 2. I do not want to solve that with a common factor of 2 hanging out, so divide everything by a 2. And it is not going to factor, but I think completing the square is working well for me today, so I'm going to go with that. I'm going to add 1 to the other side and complete my square. Half of negative 2 squared is 1. So I have x minus 1 quantity squared equals 2. Square rooting both sides. I'm left with plus and minus 2, and then final answer, add the 1. So these were irrational answers. That's why I wasn't going to be able to find them easily on my calculator without resorting to decimals. The 1/2 was the only nice pretty 0, but they're all 3 of them are real zeros. So my zeros were at 1/2, and then 1 plus and minus square root of 2. So I found 1, 2, 3 zeros in that problem. And then number 12. So on number 12, we are going to graph the polynomial, so we can kind of cheat and get a starting point for our synthetic division. I'm going to use half of my last polynomial, plus 30. So, let's see. Well, there's only one real intersection point there, and it looks like it's at negative 3.5. So I'm going to go with synthetic division on negative 3.5. Generally speaking, they're not going to be decimal x-intercepts, but for some reason we've had a lot of decimal x-intercepts. So I have a 1 x to the third, I have as placeholder 0 x squareds, negative 19, and then 30. Now you can use your calculator if you're terrified of the decimal. This is negative 3.5. And then, let's see, I guess we could do decimals. 12.25, yuck. And then, oh goodness. This is negative 6.575, excuse me. And then, negative 6.75 times negative 3.5 is not what I wanted. So what that must mean is this x-intercept is something else. Let me find it with the calculator. Sorry. Oh, left bound, negative 5. Right bound, negative 2. Oh, that's not pretty at all. I think this problem has a typo in it. We're going to scribble out this question. Because I wouldn't have you do this unless you had an obvious x-intercept. So unfortunately, I don't know an easy way to fix it, so it's something that's doable for us. I apologize. Let's try number 13. Hopefully this one gives us a more obvious problem. Like I said, in your homework, it'll be a very obvious x-intercept. Probably won't even be decimals. Plus 30. So, that's not good. Well, I think we can actually, oh, let me go back to the previous question for a second. Ha! I don't think I'm supposed to do synthetic division. I just realized something. It is a trinomial, even though it's not a quadratic. I think it is a trinomial that I can solve through some other methods. And I won't be doing synthetic division to break it down, but I think factoring will lead me to my right answer. So, I'm sorry, that was silly of me. Any day now, pen. If I try to factor this, let's see, 30, I lied again. I don't know how to factor that, so we're not going to do that question. Alright, 13. This one I can factor. X squared times x squared will give me x to the fourth, and then 30 adds up to 11. I'm thinking a plus 5 and a plus 6. Now, if I wanted to, I believe the question was solve these, find the zeros. They're all going to be imaginary, and that's why when I graphed it, I didn't see any x-intercepts because they're imaginary. So here, I'm going to get plus and minus I squared to 5 when I square root, and here I get plus and minus I squared to 6. So again, I want you to notice the complex conjugate pairs are showing up with each other. Positive I squared to 5 and negative I squared to 5. And same thing with the I squared to 6. And I just found 1, 2, 3, 4 zeros. And I noticed this was a degree of 4, which means I should have found 4 zeros, and I think I have all of them. Find the zeros of the polynomial function, then write as a product of linear factors. So we can try many methods, but this is a cubic that I think we're going to be able to reduce by synthetic division. So back to that process. Hopefully I'll get that one question fixed before we do our lesson, so sorry. 6x to the third plus 13x squared minus 4. Alright, very clear zeros. I see 3 of them are going to be real, so I won't be having any imaginary zeros. I think this is a negative 2. So I'm going to start my synthetic division process with a negative 2. And I'm going to take this cubic, and it's going to whittle down to a quadratic. So 6x to the third, 13x squared, 0 x's to the first, and a negative 4. So remember, if I've done this properly, I should be seeing a remainder of 0. And I do. So the resulting quadratic is something that I'm going to be able to hopefully factor. And they wanted a few answers. They want all the zeros listed, and then they want me to go back and write this polynomial as a product of its factors. So, I'm hoping this factors. Let's try. I'm thinking 3x and 2x. And then what if I put a plus 2 here and a minus 1 here? That would be a 4 minus 3. So the zeros, when I go ahead and solve everything, remember I had a 0 at negative 2 that I already used for synthetic division. I also have a 0 at negative 2/3. I also have a 0 at positive 1/2. And then my polynomial, when I write them as a product of linear factors, I'm going to go back to these factors that I just kind of quickly solved, rewrite them as their factors. They are linear factors, you'll notice. And then there's one more factor that's kind of hiding in this problem. If I have a 0 at negative 2, that means I have a factor of x plus 2. So both of these things are what they want to see for the answers. Here's the zeros, here's my polynomial written in factored form. Alright, I think we're almost done. 15. So, on a calculator, I would like to get a little assistance to see if I could whittle this cubic down to a quadratic. So I have x to the 3rd power plus 2x squared minus 9x minus 4. I'm going to graph that. Got some nice clear answers. 1, 2, 3 of them are real. We're going to have no imaginaries. Man, I'm thinking negative 1, 2, 3. Negative 4 is a good place to start. So synthetic division with a negative 4. My coefficients are 1, 2, negative 9, and negative 4. Remember, if he is a 0, then we should have a remainder of nothing. So that's a negative 2. This could be a positive 8, which is a negative 1, which is positive 4. Good, we did this well. X squared minus 2x minus 1. Unfortunately, I don't think that, I know that doesn't factor. So, it's going to be difficult to write it as a product of linear factors because it looks like our answers are going to be irrational. So when they say write your polynomial in its factored form, even though it said linear factors, we're actually not going to be able to write this one as a product of linear. This one's going to be a product of linear and quadratic. So his linear factor was the x plus 4 because of his negative 4 here. And then the quadratic component looks like that. So that's the polynomial in factored form. But the zeros, I see there's one at negative 4. And then for these zeros, we're going to have to either complete the square or use quadratic formula. And you know I love completing the square. So I think I've already actually solved this problem earlier in the notes. That's okay. So I have x minus 1 squared equals 2. Square root both sides. Plus and minus square root of 2. So my other answers are 1 plus and minus square root of 2. So I have 3 real zeros. 2 of them happen to be irrational. That's why they weren't real pretty. And the polynomial itself looks like this when it's factored, and the zeros are listed right there. And I believe that is the lesson.